here we go, 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 here we go. And welcome back to another episode of Containers on the Couch. It seems like only yesterday. Oh, actually, it was yesterday that we were here as well. But still, thank you very much again for joining us. It's good to see everybody here in the stream as well. Please say hi, wave, make some noise in the chat. We would like to say hello. And of course, if you have any questions during the show, please feel free to drop them in the chat. My name is Skylar Casing. I'm a developer advocate with the ECS service team in AWS. And today we have an exciting episode with a very interesting person. Firstly, I love your name. Skylar is a very unique name. I think Mesh is also kind of unique, but I
don't know.
But still, you can introduce yourself because I'm probably going to make a mess of it anyway. So please, Skylar, please tell us who you are, why you're here, and what are you going to talk about today?
Sure. Mesh, first off, I'm so thrilled to be here. To be here and be able to share with the community how Smartsheet is leveraging containers to revolutionize our service. I would like you all to envision for a moment Smartsheet as this expert pit crew in a high-stakes car race, empowering teams to rapidly build digital solutions, just like a pit crew swiftly makes crucial repairs and adjustments during the race, keeping the drivers competitive. Now, let's step into the shoes of a senior principal software engineer at Smartsheet. The goal isn't to just design and implement, it's really to pioneer. We're all about revolutionizing scale, functionality, and security, while simultaneously pushing the tech envelope. It's like weaving a tapestry where technology threads intersect with wider business objectives, a strategy that cemented Smartsheet's position in an ever-evolving digital work management area.
Well, that's a lot to take in. It sounds pretty complicated. So that's what we're here for. So let's kind of dive into what we're talking about. Can you talk a little bit about Smartsheet's journey or odyssey to the cloud in AWS and how that actually worked?
Yes, I'm so glad you asked that. Well, hop aboard. Smartsheet's foray into the cloud was akin to climbing a mountain. Our base camp was the monolith. It was a one-stop solution serving all of our needs up until that point. To meet our needs for the future, we set our sights on the summit in the AWS cloud. And thus, our expedition really started to begin. With the compass of decomposition, we shattered the monolith into smaller and more manageable parts. I mean, one way you could picture this as your climbing team breaking into specialized units, each of those teams mastering a particular landscape of the ascent. Our journey was illuminated by the flashlight of containerization. It was like wrapping our applications in these self-sustained units, much like packing all of our essential climbing gear into this handy backpack. Our final push to that peak was facilitated by the adoption of AWS managed services. These are innovative tools such as Fargate and the use of Graviton. Imagine these as all of our mountain guides. We set up our camp at the peak in the AWS cloud. And Mage, you wouldn't believe the view from here. We witnessed a more mature, optimized, and agile Smartsheet, one that was really, really benefiting from this cost-effective and high-performance fruits of the journey.
That is so interesting. So you use containers to, I would say, elevate your company, streamline your workflows, add up your, I would say, increase your resource utilization for less money. I don't know what that sounds like a dream. Is that actually what it is?
Mish, I mean, I really couldn't have said that better myself. By adapting containers, we managed to carve out specific services like the grid service, and from what once was this formidable monolith that we called App Core, this transformation not only brought about this sense of team autonomy, but it also paved the way for us to deploy, operate, scale all of our applications independently. You'll soon see that we deliver updates faster and more efficiently than we ever did before.
So let's dive deeper slightly into what this diagram is, because I can see there's different applications. You have some Lambda inside there. What is this application that we're talking about here, this Smartsheets grid service?
Yes. Well, there's the infamous app core. Now, that is an entity of just rich history. For those of you not in the know, app core was the original bedrock of Smartsheet that we were built on. A classic monolith of a code base that encompassed all the functionalities of Smartsheet. Think of it as this old castle that held all the secrets to the kingdom. Now, back in the day, we didn't have the luxury of separate service teams that we now embrace. Everything, I mean, every little tweak, addition, we had to go through this monolith, making it complex and extremely rigid over time. But in particular, AppCore held the reins to what we call the grid data, or in simpler terms, the sheets that are integral to Smartsheet. But as we grew, the need for the agility and autonomy became paramount. That's where our new hero emerged. This diagram, the grid service, entered the scene. The grid service, like a breath of fresh air, took the baton from AppCore to manage all the grid data and the formulas. You can think of this as the new maestro that's conducting our Smartsheet orchestra, harmonizing every sheet of data and every formula into what we can call a perfect symphony. Today, grid service has not only simplified our operations, but it's also significantly increased our productivity. As for AppCore, well, we're currently in the process of bidding it a fond farewell. We're actively decommissioning it in favor of the smaller and more manageable separate services. And as you'll see here, this is a new era for Smartsheet for efficiency and scalability. In this particular diagram, go
yeah,
for it.
Sorry, please. No,
No.
I'm saying it sounds like music to my ears. We were talking about symphonies, maestro, so of course I couldn't not add that one in there, so that's okay. So we've talked about the past where you had your app core, and you have now a new grid service architecture. Let's dive a little bit deeper of how this actually works on containers, or how it's actually built.
For sure, I'd love to. So Maj, this diagram here, you can see we've broken up the grid service is constructed of multiple different components. There's the grid router, there's the grid API, there's an internal and a private variant. But I think what's important here is you can see each of these containers we broke up into the sidecars, individual parts. So we have things like our logging platform, FluentD. We have a logging sidecar. We use Datadog for observability. So we have a Datadog agent in there. We have our application and web server containers in here. And you can also see, I didn't put the exact numbers of how many of these tasks that we're running. What I did put is the size. We are currently using the largest size available for ECS Fargate. I believe it's 120 gigabytes memory and 16 vCPUs. And I didn't put them out, but we use a lot of them. And this is one of our uses of ECS Fargate amongst many other. But the grid service is massive, as you'll see.
And all this stuff, I assume, is deployed in some kind of way which is not what we would love to call ClickOps. There's probably a whole thing of infrastructure as code in the background. Everything is done automated. Can you tell us a little bit more about that, how that actually works internally?
Yeah, for sure. So we didn't just embrace the managed services of ECS Fargate. We also took it upon ourselves to adopt things like AWS Code Pipeline. And Code Pipeline has been also an instrumental improvement in our deployment cadence. And we'll have some metrics that we'll share with you on that in a little bit. But Code Pipeline has been just groundbreaking for us. It's allowed us to integrate directly with our, we use GitLab to build all of our artifacts. And then from there, we're able to push those into the cloud, into our container registry, which we use Amazon ECR, Elastic Container Registry. And from there, Code Pipeline can trigger and secure the final mile. And with its integrations directly into ECS Fargate, it makes it extremely simple. You need a blue-green deployment, it's there. If you want to do a canary deployment and have some sort of checks on, percentage of availability, percentage of failures, and have it auto row back, that's also there. But to be able to do that in just a configuration change, it hooks in really well with your application's CI/CD.
It sounds like an utopia and what everybody would like to get to. And I would like to, if we can, dive slightly more into what this actual grid service is, this architecture, how this actually works. Can you tell us more about the actual grid service, what it is?
Yes, let's do it, Maj. Let's take everyone on a journey here. So,
yeah, buckle up.
Yeah, buckle up, everyone. All right.
Whoa, okay. You weren't joking.
We'll go into it in a bit. Let me give a little context and kind of take you with me through the journey. Now, I am a very visual learner. So as you probably already noticed, I use a lot of analogies. Hopefully that helps paint more of this picture. And let's dive in. So let's start with the unique design of the grid service. First, it's a cell-based architecture. Now, you might wonder, why cells? Well, here's the magic.
Let me first, before we wonder why, can you explain what cell-based architecture is?
Sure. Cell-based architecture gives us a way of separating and isolating concerns between aspects of the app. Now, in this case, we'll dive into, we separate based off of the actual data that's in play. And the separation allows us better fault tolerance, which we'll also talk about, and just higher, the ability to scale is also greatly improved. So our ability to horizontally scale increases, we have better fault tolerance, and then separation of concerns.
So that was the what, and now why? We also the kind of thing with the what, I would think, correct?
Yes, that's correct. The why is because of the sheer size of data that Smartsheet deals with. In this case, the grid service is handling all of the grid data for Smartsheet. The grid data is the sheet data that resides inside of Smartsheet. This is every sheet that you create. This gets stored in our grid databases. Now, because of how much scale, we have to have many of these database shards. We call them grid shards, and there's over 100 of these shards, and they're continuing to grow. And so by being able to also adopt a cell-based architecture, which we've taken advantage with our sharded database, it gives us a lot more fidelity and control over the app, as well as security and fault tolerance.
That's really interesting. So the fact of the shards, we're talking about, they're an important part. And I remember from my previous days when I used to play around with or manage operate production systems, which, to be honest, I'm happy I don't do it anymore because I don't get woken up in the middle of the night so much anymore. So that's cool. And I remember that from sharding databases, sharding MongoDB when I used to play around with it and manage those kind of systems. So how did the sharding provide you that actual benefit here? You said performance and availability, but is there anything else inside there?
Sure. So let's use another analogy here. If we think of the grid service like this skilled conductor that's communicating with over 100 members of the orchestra, our grid shards together, these shards maintain all the sheet data for Smartsheet. We use a directory-based sharding design, which helps in the efficient organization as well as retrieval of the data. Each of these shards is like a specialized musician that's honing their skills to deliver the absolute best performance.
That sounds pretty complicated or complex, but On the other hand, it's kind of sounds logical and efficient. So you were talking about enterprise customers, huge amounts of data. So what do you actually offer which is special to these enterprise customers? Can you give us some more information about how this goes with how this works with Smartsheet?
Yes, I absolutely love this question. So we very much offer specialized features for our enterprise customers. Now, for our enterprise customers, specifically around the grid shards, we have an option where you can purchase a dedicated grid shard. What makes this unique is that you can supply us with a customer managed encryption key, for which we will then use to encrypt the shard data. We call these CMAC grid shards. It's kind of like having a private secure vault for your data within our architecture.
That sounds pretty advanced because you have, as you say, you're a SaaS provider of some sort where you have the same solution for everybody else, but in this case, it's like encrypting a certain line within a database or a table within a database, or as you say, the specific shard, which is something which enterprise customers really need that because they need to have compliance reasons, they need to have auditability of what's happening with a specific platform, and this provides them extra value. That's correct.
Yes, that's exactly correct.
We had a question which came in from the chat where A. Bratton, I think 719, if I pronounced the name correctly, I hope I did. If not, I apologize. Can you explain the difference between a shard and a partition? Because you mentioned both of these at the moment in the previous architecture. What is the difference between a shard and a partition?
Sure. Yeah, in this case, when we use shard, we're referring mainly to our data. So the grid, in this case, the grid databases, and that data being sharded into multiple different subsets. And this is because there's so much of that data that we couldn't fit that in just one database. And as well, this gives us infinite room to scale horizontally to meet growing needs for our customers. And so with our shard being for the data, this partition, which you can also use partition in another respect. In this case, shard for the data, we have a separation. Partition would probably be more similar to our cell-based architecture, where the cell-based architecture incorporates a shard into it. So the partition can incorporate the shard. So that's probably how I'd break it down. Maybe the partition being more closely related to an abstraction around compute and behavior in the app, where the shard itself being more data-centric.
So I have a question because in ECS, we have the fact of there are certain limits, or actually all over the AWS cloud, there are certain limits and quotas or service limits that you're allowed to do. And because of those things, firstly, it protects the customer from, for example, racking up a huge bill or by mistake as a result of some code or some kind of issue, over provisioning things or running up too many instances of some kind. And one of the things which we, as part of the guidance we give, is in a platform or a set of white papers called the AWS Builders Library, which is a set of white papers of how we design things within Amazon at scale. We talk about cell-based architecture. And usually what this means is that the customer comes into a load balancer, which I see over here on the left-hand side, where you come in from Route 53 to your network load balancer. And then you go into something which is called a grid router. So I assume that is some kind of a custom load balancer that you have, which knows the logic of your application and knows how to route the questions or the requests based on the shard or on the cell?
Yes. So, okay, you're exactly right. The grid router is kind of this lightweight proxy that you can think of in a way. And since, and I mentioned that our sharding, we're using directory-based sharding or referential sharding, which means that we keep a separate data store that maintains all of the lookups, which grid lives in which shard. So we're not using like a modular or hash-based sharding. we're actually using a dictionary reference-based lookup, which gives us a lot more flexibility and control. If we want to add a new shard, we can just maintain that directory structure in the same singular data store. As well, if we want to move the grids across shards, the same thing. So the grid router is our focal, the data all comes through the same funnel. The grid router is able to then look up where that grid is, since most of these APIs require a grid ID or whatever identifier we're using to denote a grid. And once we have that, the router can look up and say, all right, well, grid ID 123 lives in whatever, shard 3, stamp 3, etc. And from there, it will route it on to another layer, another partition that we have, a construct called a stamp. And so we're seeing a lot of these different containers, like the partition strategies, but a stamp is just another box around an enclosing around a subset of all the resources needed in order to fulfill that request.
That sounds complicated, and I assume it is. And of course, the interesting thing about this is that a lot of our customers are asking, can you give us an example of how you would design a cell-based architecture? And to be totally honest, it's pretty much impossible to do that. I mean, from a perfect example, because the entire logic of that, as you say, this grid router will be very, very specific to the application where is routing the traffic. It will be IDs, it will be sessions, it will be everything which is unique to your application. And there will be probably no one cell-based router or this grid router which will be similar to somebody else's in a different company. You agree with that?
Yes. Oh, 100%. Let me give a scenario that we faced and why the cell-based architecture really was necessary at our point. The grid service, given we have so much data and we have so many of these different grid shards, imagine if we didn't take this split approach. We had just a single tier of app servers that, we could still auto scale those, but now each one of those app servers need to be able to connect and communicate with each database. Imagine how many connections, all the connection pools that each one of those app servers have to have. It's bizarre. And we're limited on how far we can horizontally scale because of it. So by having multiple in this, breakdown of separate, partitions, stamps we call them, in the cell-based architecture, we can scale that all the way to 1-to-1. You can have one of these cells per each one of your shards. And at that point, you're only maintaining those connections for that single database pool to that shard.
That's fascinating. I just want to take 1 second to stop out and step out for the people that are maybe have just joined us on the stream or maybe are catching us on the recording. Today, we're talking with Skylar. Graika, is that correct? Am I pronouncing it correctly?
You did. And it's made...
Okay. Skylar Graika from Smartsheet, who's telling us all about how Smartsheet's journey to the cloud and giving us a wonderful insight onto how their system is built and a huge amount of other information. So please say hi if you would like to join. If you've just joined us, please say hello.
Yes.
So
show some love in the comments. I want to see what's going on.
We're listening. We're waiting to hear from you. So the sharding, of course, and you said we were talking about before about your customer managed keys, which allows you to encrypt the data per customer if need be. How does the grid service over here interact with different parts of the Smartsheet ecosystem?
For sure. That's a great question. So looks like we have a little chatter. Nice to have you, Hamid. Is it Hamid?
Hi, Hamid. Thank you.
So so grid service is what we would call a platform service at Smartsheet. It's essentially an internal service that communicates with other services in Smartsheet's architecture. However, it's not an open line. It's accessible only from within Smartsheet's protected network. We use mutual TLS with per service issued certificates from Smartsheet's private CA or certificate authority. And what this does is it ensures the highest level of security and access control.
And security, of course, is important. In AWS, we always like to say that security is job zero And it's the most important thing, because without security, you can never gain your customers' trust. So these, of course, the secure communications between the different services, of course, is a critical aspect. And you've given us some insight into the architecture. How does your grid service handle your writes in your system? Because I assume you get a huge amount of writes, because everybody's updating a cell inside the sheet will take a lot of data passing through into the database. So how does that work?
Great question. Jason, great to have you here.
Hey, Jason.
We have a question. We have someone studying for an AWS solutions architect and trying to soak in as much. Well, if you have any questions related to that, please ask us. And hopefully this can help you pass that. So back to your question, how do we handle writes in the grid service? And yes, we get a massive amount of writes to updating this grid data, adding new grid data, removing it. And all the writes through the grid service APIs are managed in a pretty unique way. They're not processed immediately, but instead we offload those to asynchronous jobs. Now you can think of this like running a world-class restaurant. When a customer places an order, it's not the waiter who cooks the meal. The order is passed to the kitchen to prepare. Now, our kitchen uses an efficient blend of AWS services. These include SQS, DynamoDB, ECS Fargate, Lambda, much more. Now, you may wonder, why do we need all this? Let's revisit the analogy to hit this home. The kitchen is well equipped to handle the pressures of meal preparation. The chefs can retry if a recipe doesn't go right the first time. They can handle the lunch rush by providing fault tolerance during periods of heavy demand. They deliver reliable, consistent meals, ensuring our customers' satisfaction. They're always there, maintaining the restaurant's availability. And lastly, it's easier to control and manage the operations. It's in the same vein, processing our API writes as async jobs gives us retries on failures, fault tolerance during bursts, reliability and availability, along with greater control over our operations. It's massive how much this has helped us. It's all about ensuring that every piece of data, like every customer in a restaurant, gets the attention and the service they deserve.
So we started with music, and now we're good for a good wine and dine. Let's have a look at what this grid service architecture, if there's something about more you can tell us about it.
Sure. So we talked about the stamps. We talked about the shards. Let's talk about the per shard resources. Now, anywhere we maintain data, whether it's long-term persistent or it's temporary, ephemeral, we align our data stores with the same concept. So each data store that supplements the flow, things like DynamoDB, we even consider SQS in that bucket, S3, all are created on a per shard basis. So there's per shard representations of them. So say, one of the requests is coming through for a grid, it gets routed to stamp 2, which knows about some of the different shards, because the stamps are another layer. You can have multiple stamps all the way to one-to-one. And now it gets routed to this to the stamp. And from there, it can access any of the shard-specific resources that are attached to that shard or to that stamp. So in this case, it goes to Dynamo. It leaves some metadata about the request coming in. If it gets async pushed off, it goes into the SQS queue for that specific shard. On the other side, and we'll talk about it here in a bit, there's the async receiving, consuming, which used to be in AWS Lambdas that used event source mapping with SQS. It actually just this week, we released a complete migration to consuming from ECS Fargate instead. And we can talk about the benefits of that in a bit. Hopefully cool. that gives you some additional insight.
It does give a lot of insight. Yes. Thank you very much.
Yeah. So, is there anywhere else you want to probe into this diagram?
I think not at the moment. I think we're pretty good. I see there's a lot of routing with you're talking about I would say you said hundreds of services which are talking to each other. What are you using for, I would say, the service discovery in order for these things to find each other?
Sure. That's also a great point. For service discovery, we probably have to take this back to how it got created. We create all of our infrastructure as code. Now, I know there's a lot of CDK, was it the Cloud Development Kit through AWS fans on here? Well, we kind of play with our infra as code a bit different. We take the approach of using Terraform, HCL, and we actually use Terragrant on top of the Terraform, and that allows us to create all this infrastructure you see here, all the stamps, all the shards, each app inside of it, the router, all of it. It creates it through code that's checked in, maintained just like any application code. Part of that, when it gets created, we pass around, we use heavily things like SSM, the systems manager parameters, which can then be used to collect like a string that is separated by like a comma for different, because the only time that these resources are going to change is going to be during the CI/CD of when we're creating, we're tearing down infra. At that point, we know exactly what they are. So it makes a lot of sense for us to collect all of those at the time of the CI/CD. Now, if you want to make a change and like say add a new shard, well, you're going to have to run the CI/CD. And so we're going to be able to pick that up, just add it on to our parameters, which will then be looked up inside of our app. So our application, usually at runtime, since we use ECS, we leverage very heavily ECS environment injected params, which if you're not aware, this is a feature of ECS that directly integrates with SSM parameter store, and it makes it dead simple to pull in secrets or config at runtime. Now, we use a combination of that and just environment variables that we declare as a fixed value on the host.
But one thing's for sure, please, and I don't know if I said this enough, please never, ever, and never, ever, ever, ever put your secrets in plain text environment variables. Always use, as you said, secrets manager or parameter store in order to encrypt those things and pull them out into the workloads at runtime so that these things do not stay in the clear. That's one thing I just wanted to say.
That's a really good point. And there's even, I'll even add on to that a bit. If you're using infra as code, and I know in Terraform specifically, I'll see this a lot, where you want to add some secrets, like an SSM parameter, say you're using that to store a secret, which it's fine to use SSM params to store secrets. Now, one of the problems is if you're adding that and creating it through your Terraform, you should never set the value inside of your infra as code. I mean, there's several things going on wrong here. One, it's going to get checked into your repository, like a huge issue. Never checking your secrets there. The other problem is, even if you don't check it in, when it gets processed, most of these infra as code services create some sort of like backup state. In CDK, it's CloudFormation. In Terraform, it's its own Terraform data files. Inside of that file, it'll be there as plain text. So your secret that you thought was secure is now plain text in some state file, whether that's cached on your machine or it gets persisted into your cloud environment if you're using like an S3 integration for your state. But that's bad news,
That is really bad news. So we talked about the security part, secrets, whatever. I assume that this migration or this journey was, I think, of course, it probably is, and otherwise you wouldn't be here, was a success for Smartsheet. And this, because of the scalability and performance, you improved your operational costs or reduced your operational costs by adopting the cell-based architecture. So before you give me the answer, I'd like to ask the audience on the stream, by how many percent, of course, starting from 0 to 100, do you think that Smartsheet was able to reduce their operational cost by using the cell-based architecture and using ECS Fargate? Give us a number. Just waiting for your answers in the chat.
Let's see who can get the closest. I'm really thrilled to be sharing this one. So seeing that you're engaged and and you have an idea, that's huge.
Anybody? Any ideas? 70% from Abe Rotten. Anybody else?
It's too bad we don't have
200%. Julia said 200%.
Credits to give, huh?
Unfortunately, we're not giving out AWS credits here on this show, but of course, you can always contact your account team, ask them for help if you need it, and they will be more than happy to help out. So we had 70%, 200%, 85%.
All right.
Any more takers?
I can already say.
Give us the answer, please, Skylar.
Wow. Well, those are really good guesses. So, Maj, I'm really excited. I can't say it enough to be sharing this one because it's really near and dear to my heart. I worked very closely with this project, but Smartsheet's grid service was able to achieve an 80% reduction in operational costs through moving to ECS Fargate, using Graviton, adopting this cell-based architecture. And in the process, we also eliminated so much of that operational overhead, eliminated server management, having to manually patch the security security updates in the AMIs. Huge benefits all around. All said and done, embracing a containerized strategy just completely amped up our scalability and cut costs by a whopping 80% in 6 months. I mean, just talk about a game changer.
That's amazing. And Christina was the closest out of all of them. So Christina, thank you. Kudos for you for your guesses or your hunches. Thank you very much for participating.
Yeah, I mean, Christina must be an engineer. That's my guess.
I gather. So can you give us a little bit more details? That's how your team said goodbye to your legacy service and said hello to ECS and Fargate. What did you do?
Yeah, what's the best way to put that? So picture this. I'll use another analogy. The legacy service was kind of like an old lumbering steam train. It did the job, but it was becoming far too expensive and time consuming to keep on track. We needed a sleek and quite modern bullet train. And that's where the Java-based ECS Fargate service really did step in. This, alongside with target tracking, with JVM heap custom metrics in CloudWatch, it was like we switched from coal to literally rocket fuel. And our SQS process and efficiency just took off. It was amazing.
Did it help you also, besides the fact of your efficiency, did it also help with the way your developers created the applications or how you deployed?
Yes, very much so. So by doing this, we also tapped in to what we did on our other, the more recent grid service migration as well, where now, since we had this hosted in ECS Fargate, we could tap into the code pipeline that we're using over there and be able to hook up. We could really just copy over and use the same modules. And now our CI/CD was also much more efficient, faster, and we got the same benefits there from a reduction on the time to deploy. And as well, code pipeline is pennies. I'm still surprised at how cheap that service offering is.
Some questions which I've seen, of course, and we get customers which provide this feedback of having, I would say, challenges with running Java-based or JVM workloads inside Fargate. Usually the fact that it takes kind of time for all the memory to load and get the service or the application up to speed. How did you handle that with inside your services here on Fargate?
Yeah, really good question. I have so if you do use ECS and ECS Fargate with Java, I'm going to share some huge revealings. And these are things that took many years, experimented, even in prod, things running, failing, and finally figure them out. So these will help you tremendously. Probably the biggest one, if you're using ECS Fargate with Java, is the CPU units. Now, I believe this is the same case in ECS as it is with ECS Fargate, but I could be wrong. Now, you can declare the CPU units and give it a number for each one of your containers. Now, you always have to declare how much CPU you're going to give the ECS service itself, but you're not required to actually list out how much of those units you want to give each container. Most of the time, you probably just see 0, which means it's going to be dynamic and distributed amongst the containers as they need it. Now with Java, one of the problems here is due to when you pass in the 0, what actually gets passed through to the container is as if it appears there's only one core. Even though it has access, you could have 16 cores, and even though it's 0, it could reference and use all 16. What the JVM gets passed is one, a single core. And the JVM has a lot of configuration that automatically takes place when it sees it's running for a single core. And in this case, you get serial GC. Even if you want 0 GC, you want to use multiple threads, and it is a huge limiter if you're memory bound. And we found that the hard way. That was one of the things that just allowed us just huge gains on our efficiency of running and processing inside of ECS Fargate.
That sounds very interesting. It's very good advice. Thank you very much.
Now, the other thing I would share with ECS Fargate is because you tend to see it very memory bound, what you set your memory to, let me try to explain it this way. With Fargate, what I've noticed is when you allocate or deallocate memory really quickly, it often leads to page faults. And it's one of the main metrics they show, and it can just cause instability in your service. What I found is if you get enough of these page faults, the likelihood of that task failing is pretty high. And one way that we've significantly reduced that, right, by like over 99% reduction in these failed tasks from this, is setting your initial memory, for your initial heap size, to the same value as your max heap size. And by doing that, you're reserving the memory up front. It's not using the memory by default. It still has to run, but it's reserving it in the JVM. Huge, significant benefits. So those two things, if you're using ECS Fargate with Java or you're thinking about it, make sure you include those.
Thank you very much. Those are amazing insights. Thank you, Skylar. So would you like to share some of your knowledge or some of your wisdom for the people on stream or watching the recording later on of how they can go about starting in the world of containers if they're just only starting out on ECS or on Fargate?
Yeah, that's a really good question. I would say approach it like you're learning a new musical instrument. Start with the basics, play a few notes, and then gradually you'll be playing entire melodies. Understand your application's needs. Match them with the right services. So if you're using ECS Fargate, start adopting some of the native integrations. You can tie in CloudWatch for your logs. You can tie in code pipeline for your deployments using code build and code deploy. But leverage what's natively available, and now you've just reduced how much operational overhead by leveraging managed services in these native integrations. I think one of the biggest benefits you get from tying into some of these managed services like Fargate is all the native integrations it has across AWS. Now, it does mean that by doing that, you're going to be a little more all in with AWS. But I found by embracing AWS's managed services, the value you get from that and the partnership you can build with AWS, like it's not like you're going to be stuck on AWS. There's still, if you want to move to the cloud or you have some compelling reason, there's always ways to do that. But I wouldn't limit yourself by not using them because of that. And you see this often with Kubernetes.
It's very interesting, those insights. Thank you very much. We talked about deployments and how this was architected. And a lot of people like to talk about what we call day two, even though at Amazon, we always think it's day one, and it's always day one here at Amazon. But for day two operations means, okay, you've deployed it, everything's up and working. And how do you manage these applications in production?
Yeah, that's a great question. So I would say observability is a very big part of this. And observability, you can treat it like a detective treats clues. So, like seriously, our containerized services are fitted with the detective's essentials. We got the detailed login, metrics, tracing capabilities, all of these there. We're utilizing AWS CloudWatch and other tools as our magnifying glass for the log aggregation, monitoring, and alerting. We also use Datadog that supplements it. We even got our own control center, dashboards that give us real-time insights to the performance and health of our services. Now, this is a different control center than the actual offering in Smartsheet called Control Center, just to be clear. So observability is a huge part of it. Now, the other piece is education around your CI/CD and education around the infra as code. So you have the CI/CD for your application, but you also have the CI/CD for your infra as code. And both of those need to be well understood. Now, the level of understanding is really going to come down to your organization's structure around what an engineer is, what a software engineer is. Does a software engineer embrace more of a T-shaped model where you're responsible for the full stack, for the observability, for the security, for the deployment, the dev, like what you would call DevOps, like everything. Like that's more of the T-shaped model. And you see that often in a lot of your newer tech companies. Now, there's still another model that's commonly embraced where you have a separate SRE, site reliability engineer, or DevOps that handles all of the deployment stuff. And in that case, engineers don't need to be as aware of what's going on with your infra as code deployments or the CI/CD for your app. A lot of that can just be, I mean, you can hand it over the fence to them. So the engineers can write their code, hope it works, hand it over to them, and then let's just hope it deploys and doesn't break. So the two different models, it really is going to depend. But in Smartsheet's case, we're more of the T-shaped. And so education in enough abstraction to where an engineer can effectively be able to do all those things are key. So managed services are one of those ways that we can create enough abstraction that the surface area, the breadth of an engineer's knowledge can span enough of the aspects.
We had a question. Thank you very much for that. We had a question from Frank L81, and I think I know the answer, and I'm going to kind of give you a guess, but I'll give the answer to the question the way it was asked and rephrase it slightly. Can you give us any information of how many people are needed for the show deployment? So I would assume the way you're doing it, actually to deploy this infrastructure, you need 0 people because everything's as code. So everything is done automatically with workflows and some kind of pipeline. The question, I would rephrase it slightly from Frank, if you don't mind, is how many people were needed, or if you can give us an idea that to create this deployment, all the automation in the background?
Yeah, well, you would be right. So first off, every aspect of the CI/CD has found a way to be automated. Now, there's one caveat. We always have at Smartsheet a manual gate. Well, for at least the grid service team, as example, it's not across the board, but a manual gate to ensure before we deploy to prod, there's a little bit more checks, gates that we do. Now, it could be automated, but we do this more from a like reliability, ensuring that things are safe before they go out. But the whole thing, if we wanted to, we could remove that gate and it would be all automated. The time it took to do this, I would say the time it took to actually implement it itself, well, one engineer could have done it, and maybe depending on their knowledge, 2 weeks, 4 weeks. But that to me doesn't actually solve the issue. The most important thing is the education and bringing everyone along that journey to be at the same level. So while even if they're not doing it, enough education in some sort of like way of building the muscles and getting them involved to where you're all knowledgeable about it. So when something goes wrong, and it will, I mean, Murphy's Law, everything is going to break at some point. Like,
as Werner says, everything fails all the time. Exactly.
yes.
Werner Vogels, the CTO of Amazon.
And now that you're completely hands off, it's automated. Well, when that something goes wrong, like that can be a very difficult situation because you have no way of getting your code out or no way of updating your infrastructure if it's your CI/CD for your infrastructure pipeline. So the learning and the education around it, and even once you automate it, finding some sort of processes such as like game days or other avenues that are still going to build those muscles and get you involved enough to where you're not in the dark when things go wrong.
We're coming close to the end of our hour. I have one more big question, and I apologize if we haven't gotten to all the questions in the chat. Thank you very, very much for participating. We'll try to kind of answer them throughout with the conversation. Did you have any, I would say, bumps along the way that you encountered when you were deploying or developing this architecture? And are there any things you would have changed if you would be able to start over again, wind the clock back, rewind the videotape, whatever it may be? You can actually see how old I am videotapes, but still. But is there anything you would have changed, and did you have any bumps along the way?
Sure. It's a really good question. So another analogy. Just like scaling a mountain, the view at the top is definitely worth it, but the climb can be challenging. And similarly, we grappled with multiple things. I mean, ensuring application compatibility, handling stateful workloads, arming engineers with the new tools and paradigms, as well as balancing the scales of cost and performance. However, with us being in the AWS clouds, our diligent and innovative engineering teams could be seen as our Sherpas. We were able to summit these challenges without too much turbulence. Some of these challenges, some specific examples of these challenges would be, what would be one of the, let me come back to that. But there was tremendous challenges, but we also, being in the cloud, gave us a lot more control and adaptability to be able to find a solution.
And the second half of the question, if you had to change anything, start the journey again, would you do anything different?
Yeah, I would say in hindsight, our journey was kind of this roadmap of learning, and investing earlier in our infra as code would have went a long way. And not just investing in building it, but getting engineers involved with it and kind of the educational piece. Because once you build those muscles, then it's just self-sustained and it's taken care of. New engineers join the team, they're getting taught up on the infrastructure. And I think that would have been really helpful for automating things.
Cool. Before we end, there was actually one question which I did see, which we didn't get to, and that was from Abe Bratton, and I'll put it here on the screen. Do you use any kind of, because of course this is a global service with Smartsheet that's available anywhere in the world, do you use any kind of global acceleration, CloudFront for CDN for offloading? I assume before the network load balancer, you have some kind of CDN or which is doing that kind of work?
So the grid service specifically is not using the actual global accelerator service in AWS. There are teams that use that. We do have CDNs for static content. In this case, since we're more of a platform service and we have the NLB in front, we leverage, I mean, I'm sure NLB has quite a bit of these enhancements for edge-based routing and whatnot built into it, but we don't actually use Global Accelerator itself for the grid service. Now, more of our public-facing services that are being talked to directly from the application, that's more likely. Yeah, that's probably all I can say at that point.
Okay, thank you very much. Thank you for sharing. So I want to thank you for sharing your story, of course, of how Smartsheet does, how you've evolved over time, sharing the knowledge and the learnings that you've had over time as well, and how you're using AWS and ECS and containers and Fargate. Is there anything you would like to end with before we close the episode for today? And of course, before we do that, of course, two more things. Number one is thank you very much for joining. And secondly, if anybody would like to get hold of you, I see you already put all your information here up on the screen. So either take a quick snapshot of it, or I'll try and put those also in the show notes afterwards, how people can get hold of you, if that's okay.
Yeah.
Any final statement you would like to share with everybody here?
I mean, really, just I really appreciate you having me here and being able to connect and share our journey, our vision, from Smartsheet's side as we've moved to the cloud and containers. And I hope they inspire others on their own journeys. And if you're on the lookout, we are on the lookout for new talent. So if you're intrigued by what we do, what I've said has compelled you, you want to work in the cloud, swing by our careers page. That's also listed here.
And of course, one more thing I'd like to add, because we've been talking about this the whole night. If you have any, I would say, yearning for good music or good food, as we spoke about the maestro, the orchestrator, and the kitchen, and the chef, reach out to Skylar here, please. He will be happy to answer your questions. I would like to thank everybody for joining us today. Please don't forget to hit the subscribe button on the YouTube channel. We're almost to 20,000 subscribers, which is an awesome milestone for us. So please don't forget to subscribe to the YouTube channel. If you want to also subscribe on the Twitch channel, we have not only Containers from the Couch, we have a number of other very interesting sessions and streams as well. And of course, leaving you of what's going to happen next is not a good idea. So stay tuned next week, same time, same slot on Containers from the Couch. We're going to have another episode with my counterparts in the EKS, the developer advocate team, where we're going to be talking about EKS and fault injection simulator, how you can create chaos in your EKS environment. So don't forget to join us, put a reminder in your calendar, and thank you very much, everybody, for joining. It was an awesome episode. Thank you so much.
Yeah, and one last thing. As Mage said, if you want to connect with me, do reach out. You can add me on LinkedIn. You can, add me on GitHub, Twitter. But I would love, if you have messages you want to talk, do reach out. I'm here for you.
And I'm also available on Twitter, MageSK. Feel free to either ask any questions about containers, send me a DM, reach out. Please feel free. Thank you, everybody, for joining. It was an awesome episode. Thank you very much, Skylar.
Yeah, thank you.
Have a great day.